today we're going to be conducting an experiment to find the acid content of commercial soda. A titration is a lab procedure for quantitative analysis. A titration is a laboratory procedure for quantitative analysis. Titrometric analysis is used to determine 1. The concentration of an analyte in the solution, the stoichiometry of a reaction, the number of electrons gained or accepted in a redox reaction, and solubility products.
In a titration, a known volume of a solution of unknown concentration is titrated by a known volume of a solution of unknown concentration. By knowing the titration volumes and mole ratio in which solids react, the concentration of the second solution can be calculated by using the formula molarity 1 times volume 1 equals molarity 2 times volume 2.
Calculating the volume, the number of significant figures in the result should be equal to the number of significant digits in the least precise number, which is the number with the fewest significant digits given in the problem. It is important to note that the burette was washed and rinsed with water and solution 3 times before each use.
First, we weighed 3 samples of KHP. The first sample weighed 3.036 times 10 to the negative 4. The second sample weighed 3.477 times 10 to the negative 4. And the third sample weighed 3.280 times 10 to the negative 4.
Here's an example of our 3 samples in grams converted to moles of KHP.
We filled each beaker up with 50 milliliters of water.
After filling with water, add a small amount of KHP to each beaker.
And we're pouring.
There's the 50.
KHC may dissolve slowly, so if you stir it around like this, it helps, and you want to do every sample at the same time. Yep.
3.
The initial volume for all 3 experiments was 50 milliliters.
Add a couple of drops of phenolphthalein to the KHP solution, then Now, slowly add the NaOH aqueous solution from the burette until the faint pink endpoint is observed. Okay, it's important to note to move the Erlenmeyer flask around when you're putting the sodium hydroxide in the solution so that it gets distributed evenly.
You know the endpoint is observed when it turns a faint pink in color. We performed this step for all 3 flasks, all starting with an initial volume of 50 milliliters. The final volume for sample 1 was 24 milliliters, but we didn't get it on video.
Sodium hydroxide in sample 2 is 17.5 milliliters.
Final volume of the sodium hydroxide in sample 3 is 21.5 milliliters.
Okay, wait, we got a little focus.
Sodas provided were carbonated, so the bubbles that result from the carbonation are going to cause errors in our analysis. So to remove the bubbles, you have to pour about 100 milliliters of the soda into a beaker, and then you heat it, and you have to you have to heat it for at least 15 minutes. Use a meniscus right at 100 milliliters.
Colored sodas such as Pepsi Cola or Coca-Cola cannot be analyzed by this method because their color matches the phenolphthalein endpoint. These sodas usually contain phosphoric acid.
We are determining the concentration of the citric acid by placing 20 milliliters in an Erlenmeyer flask.
15. Leigha is adding 2 drops of phenolphthalein to the citrus acid.
Now bring the sodium hydroxide to the endpoint.
74 milliliters because we took 26 milliliters from our 50 milliliter sample of sample 1, and we got 6 left in here, as you can see by the meniscus. So we took 24 milliliters, and we have 74 milliliters as our final volume.
For every 1 mole of KHP, there is 1 mole of sodium hydroxide. Here are our notebook calculations showing the molarity of sodium hydroxide and citric acid in commercial soda.